This is Dreamtime Science, where we paint the canvas of your dreams with the soft brushstrokes of scientific wonder. Together we'll explore the mysteries that dance at the edge of consciousness. You know, I've been thinking about how incredible it is that sometimes the sun seems to disappear for just a moment, like the sky is playing a quiet cosmic trick on us. There's something remarkable about the way the Earth, Moon and Sun line up just right to create these rare, fleeting shadows, almost like a perfectly timed dance in space. I'm really excited to share what makes eclipses happen and why they don't come around as often as we might expect. If you find peace in these nocturnal discoveries, consider becoming a regular visitor to our quiet corner of science. Share in the comments what topic you'd love to dream about next. Let's prepare for tonight's journey. Find your most comfortable position, let tension float away from your body, and take 3 slow, peaceful breaths. In the hush of twilight, as the world softens and settles into the velvet folds of night, the mind too grows receptive, ready to be led through the corridors of wonder that science and story so often share. It is in these liminal hours that thoughts of celestial events, those grand spectacles of shadow and light, take on an almost mythic quality. Among them, eclipses stand apart, mysterious and dramatic, weaving together the predictable clockwork of the heavens with the unpredictable tapestry of human imagination. A dance of shadows. This is what an eclipse truly is, no matter how it has been understood or interpreted across centuries. At its simplest, an eclipse occurs when one celestial body moves into the shadow of another. On Earth, this most often means the interplay between the sun, the moon, and our own planet, choreographed with impossible precision. Yet to call it simple would be to miss the point entirely. The mathematics may be straightforward, the geometry measurable, but the meaning, has always reached far beyond the mere alignment of orbs. Let us then begin not with the calculations of astronomers, but with the trembling awe and cunning resourcefulness of a single man lost in time. Samuel Clemens, better known as Mark Twain, gifted the world a fable that captures the enduring magic and terror of an eclipse. In his novel, A Connecticut Yankee in King Arthur's Court, a 19th century engineer is thrust backward through the centuries, finding himself a stranger among the knights and castles of Arthurian legend. Stripped of his technology and knowledge of the modern world, he is left with only his wits and, crucially, his memory of a coming solar eclipse. Imagine the scene. The Yankee, imprisoned and facing execution, remembers from his almanac that a total solar eclipse is due on a particular day. The moment arrives with the sun blazing overhead, life in the medieval court proceeding with its usual pageantry and superstition. As the moon begins its inexorable creep across the face of the sun, a hush falls. Shadow swallows the land. Birds quiet, dogs whimper, and the air chills as if the world itself is holding its breath. To those present, it is as though the gods have withdrawn their favor, or a mighty curse has been laid upon the kingdom. The Yankee, seizing this moment, proclaims himself a mighty sorcerer, threatening to blot out the sun forever unless his life is spared. Here is the power of eclipses, writ large not only in the skies, but in the hearts of those who witness them. For the medieval mind, unacquainted with orbital mechanics, the sudden obliteration of the sun is a terror beyond words. And for the shrewd, like Twain's protagonist, it is an opportunity, a lever by which to move the world. In this story, the eclipse is not merely an astronomical event, but a fulcrum upon which fate itself turns. This scene, though spun from the threads of fiction, is rooted in the very real reactions that eclipses have evoked throughout history. For as long as humans have gazed upward, the sudden darkening of the sky during the day, or the uncanny reddening of the moon at night, has provoked fear, awe, and a desperate search for meaning. Ancient peoples read these events as omens, messages from the divine, or warnings of catastrophe. In China, dragons were believed to devour the sun during an eclipse, prompting villagers to bang drums and fire arrows skyward in an attempt to drive the beast away. The ancient Greeks, for all their rational inquiry, saw eclipses as portents of doom, the gods signaling their displeasure with mortals below. Even in the age of science, the emotional resonance endures. When the moon's shadow sweeps across the earth, plunging day into an otherworldly twilight, even the most rational mind feels the tug of something ancient, something primal. The air cools, birds fall silent, and for a few brief minutes the familiar order of things is overturned. It is a reminder that for all our understanding, we are still creatures of the earth, subject to the rhythms and mysteries of the cosmos. But what precisely is an eclipse? The answer, though simple in outline, is profound in its implications. A solar eclipse occurs when the moon passes directly between the earth and the sun, casting a shadow upon the surface of our planet. Depending on the precise alignment, this shadow may fall in one of two forms. If the moon is close enough to Earth in its slightly elliptical orbit, its apparent size is sufficient to cover the entire disk of the sun, resulting in a total solar eclipse. For those lucky enough to stand in the narrow path of totality, the world is transformed. The sun's corona flares in ghostly tendrils, the sky darkens as for twilight, and a hush falls over the land. Beyond this narrow corridor, observers witness a partial eclipse, a crescent sun, oddly diminished but never fully obscured. At other times the moon is just a little farther from Earth, its disk slightly smaller than the sun's. In these moments, an annular eclipse occurs, with the sun forming a brilliant ring, or annulus, around the dark silhouette of the moon. Each type, whether total, partial, or annular, is a testament to the exquisite geometry of our solar system, a cosmic coincidence that the moon and sun appear, from our vantage point, almost exactly the same size in the sky. Lunar eclipses, by contrast, occur when the Earth itself interposes between the sun and the moon. Here, it is our own planet that casts a shadow, and the moon, bathed in the filtered ruddy light of countless sunsets and sunrises, takes on a coppery glow. This blood moon, as it is sometimes called, has haunted the imaginations of poets and prophets alike. Unlike solar eclipses, which can be seen only from a narrow swath of the earth, a lunar eclipse is visible to all who gaze upward from the night side of the planet, drawing entire civilizations into a shared moment of wonder. Through all of this, the essential ingredients are the same: alignment, timing, and the interplay of light and shadow. Yet these ingredients have been mixed and interpreted in countless ways. In the hands of storytellers and myth-makers, eclipses become more than mere astronomical events. They are woven into the very fabric of legend, prophecy, and power. Consider for a moment the role of eclipses in the tales we tell. In Twain's A Connecticut Yankee in King Arthur's Court, the eclipse is a weapon, a miracle, and a display of knowledge mistaken for magic. This motif is echoed across the ages. In H.G. Wells's The Time Machine, the protagonist describes the sun as waning in the far future, evoking the unease and dissonance that shadow can bring to the heart of day. In movies and television, eclipses signal turning points, moments when the ordinary rules are suspended and something extraordinary may happen. The shadow that falls across the land is never just a shadow, but a veil between worlds, a harbinger of change. Popular culture, ever attuned to the rhythms of fascination and fear, has embraced the eclipse as a symbol of the unknown. In the animated film The Lion King, a solar eclipse marks the villain Scar's usurpation of the throne, the sun's disappearance underscoring the unnatural disruption of the natural order. In the television series Heroes, the recurring eclipse motif signals the emergence of superhuman abilities, a cosmic trigger for transformation. Even in the realm of music, eclipses are invoked to conjure mystery and longing. The haunting refrain of Pink Floyd's Eclipse echoing in the minds of generations. Yet science fiction perhaps most fully exploits the power of eclipses, using them as plot devices, metaphors, and moments of revelation. In Arthur C. Clarke's 2001 A Space Odyssey, the film's iconic opening scene features a solar eclipse, the alignment of sun, moon, and earth, hinting at cosmic mysteries beyond human comprehension. The eclipse becomes a gateway, a symbolic crossing from the known to the unknown, from the mundane to the miraculous. Returning then to the Connecticut Yankee, we see that Twain's use of the eclipse is more than a clever plot twist. It is a meditation on the power of knowledge, the relationship between science and superstition, and the thin line between awe and terror. The protagonist's prediction of the eclipse is not magic, but science. Yet to those around him, the distinction is meaningless. The eclipse becomes a test of faith, a trial of power, and a moment when the very fabric of reality seems to tremble. This interplay between knowledge and mystery is at the heart of the human experience of eclipses. For the astronomer, the eclipse is a predictable event, calculated to the second, its path mapped with exquisite precision. For the poet, it is a metaphor, a sudden darkness, a crisis, a moment of transformation. For the ordinary observer, it is both, a phenomenon that can be explained and yet still feels, in the moment of its occurrence, like something more. There is perhaps an even deeper lesson here. The eclipse, in all its forms, reminds us that the universe is both knowable and mysterious, both orderly and astonishing. The alignment of sun, moon, and earth is not a random occurrence, but the result of celestial mechanics, the slow dance of bodies through the void. Yet the experience of an eclipse, standing in the shadow, feeling the chill, watching the stars appear in midday, transcends explanation. It is a moment when the familiar is made strange, when the boundaries between science and story blur and dissolve. Across cultures and centuries, the eclipse has been a source of inspiration and fear, a canvas upon which we project our hopes and anxieties. It is a testament to the power of shadow, to the ways in which absence can be as meaningful as presence, and to the enduring human need to find meaning in the movements of the sky. As we drift deeper into this nocturnal journey, let the image linger. A kingdom held in thrall by darkness, a lone figure standing between knowledge and ignorance, and above them all the shadow of the moon sliding inexorably across the sun. The world holds its breath, the old order trembles, and for a moment anything seems possible. What other secrets might these cosmic shadows conceal? What new worlds might be revealed when the veil of light is drawn aside, if only for a moment? The story of eclipses, it seems, has only just begun to unfold. The night is gentle, its darkness draped across the world like a velvet shawl. Somewhere, perhaps in a quiet garden or on a lonely hilltop, someone looks up, eyes searching the heavens for a sign, a story, or perhaps just solace in the silent turning of the sky. Throughout history, the sudden disappearance of the sun or the transformation of the moon's familiar face has roused awe, fear, and wonder. Yet as we draw closer, the shadows reveal their secrets, and what once seemed a portent or a curse unfolds as an exquisite choreography, governed by the profound logic of nature. Let us, for a time, become wanderers in this cosmic theatre, moving with patient curiosity through the intricate dance that leads to an eclipse. To understand this celestial ballet, we must first acquaint ourselves with the main dancers, the sun, the earth, and the moon. Each is a world unto itself, vast and powerful, yet their movements are not solitary. Invisible threads, gravity, momentum, geometry, bind them into a system of perpetual motion. It is in the rare moments when their paths cross in just the right way that the stage is set and the spectacle unfolds. Begin by picturing the sun, an enormous sphere of incandescent plasma, 100 times the diameter of our Earth, radiant and constant. While it appears small from our vantage, its searing light sustains all life, and its gravitational pull anchors the planets in their endless orbits. Next, the Earth itself, a blue marble tracing its long elliptical path around the Sun, spinning gently, turning night into day. And finally, our companion, the Moon, a desolate, cratered world, forever bound to us by gravity, circling once every 27 1/3 days, its phases marking the passage of time. And now, let us consider what it takes for an eclipse to happen. Imagine these three bodies, drifting in the vastness of space, each moving according to its own rhythm. For an eclipse to occur, they must align with astonishing precision, a feat not of random chance, but of celestial mechanics. The Moon's orbit is tilted by about 5 degrees relative to the Earth's path around the Sun. This small angle means that most months the Moon passes either above or below the line connecting the Earth and the Sun. Only when the Moon's orbit crosses this line, at points called nodes, is an eclipse possible. Consider the geometry of a solar eclipse. The Moon glides between the Earth and the Sun, casting a shadow upon our world. The shadow is not a vague darkening, but an elegantly defined cone, narrowing to a fine point as it stretches toward Earth. Within this umbra, the Sun is completely hidden, and day becomes night for those standing in the shadow's path. Beyond the umbra lies the penumbra, where only a portion of the Sun is obscured, softening the light but not erasing it. The alignment required is so exact that, despite the orbit's regularity, solar eclipses are rare at any given location, perhaps once in several centuries. The Moon itself, though small, just 1/4 the diameter of Earth, finds a way to match the Sun's grandeur. The Sun is 400 times wider than the Moon, but it is also 400 times farther away. This remarkable coincidence means that from Earth, the Sun and the Moon appear almost the same size in the sky. It is this balance, this delicate interplay of distance and scale, that allows the Moon to cover the Sun so precisely, painting a black disk against the blazing sky and unveiling the pale, ghostly corona, a crown of solar plasma that is otherwise invisible. Yet not all eclipses are created equal. Sometimes the Moon is slightly farther from Earth in its elliptical orbit, and its apparent size is just too small to cover the Sun completely. In these moments, an annular eclipse occurs. A brilliant ring of sunlight encircles the black Moon, a ring of fire suspended in the heavens. The mechanics of this variation, this subtle difference in distance, add layers to the cosmic choreography, ensuring that no two eclipses are ever quite the same. Lunar eclipses, too, are woven from the same fabric of geometry and chance. Here, it is the Earth that takes center stage, sliding between the Sun and the Moon. The Earth's shadow, vast and conical, envelops the Moon, slowly painting its surface with shades of copper and crimson. Unlike solar eclipses, which can only be seen from a narrow path, lunar eclipses unfold across the entire night side of Earth. Millions may look up and share in the spectacle as the shadow creeps across the lunar face, a slow and stately transformation. But why does the Moon turn red rather than vanish entirely during a lunar eclipse? The answer lies in the air we breathe. Earth's atmosphere, thin and fragile, bends sunlight as it passes through, filtering out the blues and greens and allowing the reds and oranges to slip through. These refracted rays bathe the Moon in a faint, ruddy glow, a silent reminder of the interconnectedness of all things, from the dust in our lungs to the glow on a distant world. For millennia, such sights have stirred the human imagination. Myths and legends abound, stories of dragons devouring the sun, of gods waging war, of omens and destinies written in darkness. Yet the true tale, unveiled by the patient work of astronomers and mathematicians, is no less wondrous. It is a story of motion, of cycles within cycles, of a universe governed by laws that are at once simple and profound. To see this, let us peer more closely at the mechanics of those cycles. The Moon's orbit is not a perfect circle, but an ellipse, and its nodes, the points where its path crosses the plane of the Earth's orbit, slowly drift, completing a revolution every 18.6 years. This precession means that the conditions for eclipses shift over time, creating patterns known as Saros cycles. Each Saros lasts about 18 years, 11 days, and 8 hours, after which the geometry of the Sun, Earth, and Moon nearly repeats, and a similar eclipse occurs. Ancient astronomers, attentive to the cadence of the heavens, learned to predict eclipses by tracking these cycles, transforming what seemed random and fearsome into something ordered and comprehensible. Yet, even with such knowledge, the experience of an eclipse remains profoundly moving. To stand in the path of totality as the Moon erases the Sun is to witness nature's grandest illusion. The temperature drops, birds fall silent, and the midday sky darkens to twilight. Stars emerge, planets shine, and the world is transformed for a few brief minutes. The rational mind knows the cause, yet the heart cannot help but feel awe at the sheer improbability of it all. The interplay of orbits, angles, and timing is so precise that even slight changes could render eclipses impossible. Imagine, for a moment, a world where the Moon was a little farther away, or the Sun a little closer. The perfect alignment would be lost, and the sky would never host the drama of a total eclipse. In the distant past, the Moon was closer to Earth, and its shadow traced a wider path. Over the eons, tidal forces have pushed it ever outward, and in a few 100 million years, total solar eclipses will be no more. Only annular eclipses will remain, the Sun's blazing ring unbroken. This ongoing change is a testament to the restless dynamism of the cosmos. The Earth and Moon are locked in a gravitational embrace, each tugging upon the other, raising tides in the oceans and even in the solid rock beneath our feet. These tides act as a brake, slowing Earth's spin ever so slightly and pushing the Moon away at the measured pace of a few centimeters per year. The cosmic ballet is never static. Its choreography evolves, generation upon generation, written in the slow language of time. As we follow these orbits and their shifting alignments, it becomes clear that eclipses are not omens of doom, but natural consequences of the universe's geometry. They are moments when the ordinary rules of day and night, light and shadow, are momentarily suspended and rewritten. The universe is impartial, guided not by fate or malice, but by the persistent unfolding of physical law. Still, there is a poetry in the patterns. The shadow's path across Earth, the Moon's glowing transformation, the interplay of light and darkness, these are reminders that though we are small, we are part of something vast and harmonious. The same laws that guide the turning of galaxies, the dance of atoms, and the beating of our hearts also govern the eclipses we watch from our small blue world. Step further into this dance, and you'll find subtle variations, partial eclipses, where the Sun or Moon is only partly obscured, penumbral lunar eclipses, where the Moon passes through the faint outer shadow of Earth, dimming only slightly. Each variation is dictated by the precise geometry of the moment, a testament to the endless possibilities within the system. No two eclipses are identical. Each is shaped by the shifting interplay of orbital distances, speeds, and inclinations. The ancients, watching the sky with attentive eyes, could not have known the equations that govern these motions, but they sensed the regularity, the recurrence, the pattern beneath the surface. Their myths gave meaning to uncertainty, but as knowledge grew, the myths gave way to a deeper reverence, a respect for the elegance and inevitability of the cosmic ballet. And so, when next you hear of an eclipse, whether a rare totality, a fleeting annular ring, or a coppery lunar transformation, let your thoughts drift beyond the stories of old. Consider the mathematics encoded in every shadow, the physics inscribed in every orbit, the improbable symmetry that allows a small grey moon to conceal the face of a star. Each eclipse is a whisper from the universe, a fleeting alignment that links sky and earth, past and future, chance and necessity. The dance continues, eternal and ever-changing, written in the unyielding language of gravity and light. And as the shadow falls and the world stands hushed in the sudden twilight, we are reminded of our place in the turning cosmos, a place both ordinary and miraculous, suspended between darkness and dawn. Beyond the horizon, the moon continues its silent journey, the sun blazes on, and the earth spins in their midst. The mechanics that bring about eclipses remain steadfast, while the stories we tell are ever renewed. Soon we shall listen more closely to the whispers carried by these shadows, how they have shaped the minds and spirits of those who watch them, and how the pursuit of their understanding has driven us to look ever deeper into the night. It is a curious thing to measure the shape of darkness, to chart the edges of a shadow falling across the earth from a celestial body so far away, and to read secrets from the way that twilight bends and dances. Yet, for as long as human eyes have turned toward the heavens, eclipses have offered both terror and revelation, a flicker in the sky that hints at hidden order, at mysteries waiting to be unraveled by patient minds. On a warm May morning in 1919, beneath the heavy, trembling hush of a world awaiting transformation, a slender Englishman named Arthur Eddington stood on the tiny island of Principe off the coast of West Africa. He waited not for the dawn, but for its silencing, the dark hand of the moon preparing to sweep across the face of the sun, blotting its brilliance, if only for a moment. Eddington was not alone. Across the narrow Atlantic, another team waited in Sobral, Brazil, their telescopes poised in anticipation. These astronomers, scattered on the far side of the world, were united by a singular quest, to chase the fleeting shadow of a solar eclipse, and, in its vanishing light, to weigh the very fabric of the universe. But to truly appreciate the significance of that momentous day, we must journey first through the labyrinthine corridors of eclipse history and marvel at the ingenuity that has, for centuries, turned moments of celestial darkness into beacons of knowledge. For ancient peoples, eclipses inspired awe and dread in equal measure. The sudden vanishing of the sun or moon was no ordinary occurrence. It was portent, omen, disruption. In Babylonian tablets, careful scribes recorded the timing and appearance of eclipses, seeking patterns, striving to appease the gods. The Chinese, too, chronicled eclipses with meticulous precision, their imperial astronomers charged with warning the emperor, lest the sun's disappearance spell disaster for the realm. Yet even as myth and superstition flourished, so too did the first glimmers of scientific curiosity. The Greek philosopher Anaxagoras, in the 5th century BCE, dared to suggest that eclipses were not the work of capricious deities, but the result of celestial bodies casting shadows upon one another. The moon, he argued, was a rock, not a lamp. Its phases and its ability to obscure the sun could be explained by geometry, not magic. By the time of Aristarchus and Hipparchus, eclipses had become tools for measurement. Hipparchus, observing a lunar eclipse, used the geometry of the Earth's shadow to estimate the distance to the moon. His reasoning, though crude by modern standards, was an early triumph of inference from shadow. Centuries later, the Persian polymath al-Biruni deduced the radius of the Earth by watching the moon's shadow sweep across distant horizons, a quiet testimony to the power of careful observation. Yet it was the total solar eclipse, that rarest of celestial spectacles, that truly beckoned the world's scientists. In those minutes, when the sun's blinding glare is quenched by the interposing moon, the corona, the sun's ethereal outer atmosphere, blooms into view, a silvery halo of plasma streaming outward into the void. For most of human history, this corona was invisible, lost in the sun's brilliance. Eclipses revealed it as if by magic, each one a fleeting laboratory in the sky. In the 19th century, eclipse expeditions became grand affairs. Ships loaded with telescopes, astronomers, and crates of photographic plates set sail for distant lands, racing the clock to catch a few minutes of darkness. With every eclipse, new discoveries spilled forth. In 1868, the French astronomer Jules Janssen, observing from India, noticed a strange bright line in the sun's spectrum, visible only during an eclipse. It was an element unknown on Earth, helium, named for the sun itself, discovered not in the ground but in the heavens. Others followed, charting the corona's structure, its shifting forms and ghostly streamers. Some tried to measure the sun's heat or to glimpse signs of elusive planets hidden near its glare. Each eclipse a chance to ask new questions, to probe the limits of what could be seen and measured. But no eclipse would prove as consequential as the one that unfolded in 1919. To understand why, we must step for a moment into the mind of Albert Einstein. In 1915, after years of struggle and isolation, he unveiled his general theory of relativity, a radical new vision of gravity. Gone was the notion of gravity as a force, pulling objects together across the emptiness of space. Instead, Einstein described a universe where mass and energy bend the very fabric of space-time itself. The sun, immense and heavy, warps the space around it, and light, though massless, must follow the curves of this invisible landscape. The prediction was bold. A ray of starlight passing close to the sun would be deflected from its path, not by the sun's heat or magnetic fields, but by the warping of space itself. The effect was tiny, a mere arc-second or two, but measurable, and yet, under ordinary circumstances, the sun's overwhelming brilliance makes it impossible to see stars near its edge. Only during a total solar eclipse, when the moon masks the sun's glare, can the stars peeking out from behind the sun be seen at all. Thus, the 1919 eclipse became a crucible, a rare alignment of celestial bodies, a chance to test the strange geometry of Einstein's mind against the reality of the cosmos. Arthur Eddington, an astronomer of quiet conviction and mathematical prowess, was among the few who grasped the stakes. The world, shattered by the Great War, was hungry for unity and understanding, and here, in the arcane dance of eclipse shadows, was a chance to bridge continents and ideas. Eddington arranged for 2 expeditions, one to Principe, where he himself would travel, and another to Sobral, led by his colleague Andrew Crommelin. The preparations were exhaustive. Special telescopes designed to minimize distortions and withstand tropical humidity were packed and shipped. Photographic plates, the delicate glass sheets that would record the fleeting positions of stars, were carefully chosen and tested. Charts of the target stars, those near the sun's predicted position during totality, were assembled so that their peacetime locations could be compared to their wartime positions, with the sun intervening. Even as the world waited, the shadow advanced. On May 29, 1919, the moon began its slow passage across the sun, and, for a few precious minutes, day became night. In Principe, clouds threatened to thwart the observations, but parted just enough for Eddington and his small team to capture several crucial plates. In Sobral, conditions were clearer, and Crommelin's team secured a trove of images. The weeks and months that followed were a study in patience and precision. Back in England, the photographic plates, faint, crowded with the ghostly dots of distant stars, were measured and remeasured, their positions compared to reference plates taken at night, when no sun intervened. The measurements were minute, the differences subtle. Were the stars near the sun shifted outward by the precise amount Einstein predicted, or did they follow the path Newton's laws would dictate? The answer, announced to a rapt world that autumn, was clear. The stars' positions, as seen during the eclipse, were displaced by just the amount general relativity required, twice the shift Newtonian gravity would have produced. The sun had bent the starlight, not with force, but with the shape of space itself. The newspapers trumpeted the result. Revolution in science, new theory of the universe, Newtonian ideas overthrown. Einstein, overnight, became a household name. But the true triumph belonged to the eclipse, to the shadow that in passing revealed the curvature of the cosmos. Behind this moment of revelation lay a tapestry of ingenuity and perseverance, woven from decades of eclipse science. The challenges were immense. To observe stars near the sun, one needed perfect alignment, clear skies, and exquisitely calibrated equipment. Even the act of transporting delicate telescopes to remote corners of the globe was an ordeal. The photographic plates, sensitive to temperature and humidity, could warp or crack. The telescopes themselves, battered by wind or shaken by shipboard journeys, required constant adjustment. Timing was everything. The interval of totality, the only window in which the stars could be glimpsed, lasted mere minutes. And then there were the calculations. The position of each star, measured in fractions of a millimeter on glass, had to be compared with its known location, accounting for every possible source of error. Atmospheric turbulence, optical distortions, even the flexing of the telescope's metal frame as it warmed in the sun. Only by pooling data from multiple plates, multiple telescopes, and multiple locations could a consensus emerge. Eddington's triumph was not without controversy. The uncertainties were real. The measurements, while statistically significant, hovered near the threshold of what could be confidently claimed. In the years that followed, skeptics would debate the details, and further eclipse expeditions would refine the result. But the principle, the bending of light by gravity, the warping of space around mass, stood firm, a cornerstone of modern physics. The legacy of eclipse science stretches far beyond that singular experiment. With each passing shadow, astronomers have gleaned new insights: the composition of the solar corona, the behavior of solar flares, the elusive dance of particles in the sun's magnetized wind. Eclipses have been used to probe the subtle structure of our atmosphere, to test the limits of human vision and photographic technology, to inspire poets and painters alike. At the heart of it all is a paradox. In the briefest darkness we see most clearly. The shadow that falls across the land is not an end but a beginning, a window flung wide, if only for a heartbeat, onto realms otherwise hidden. The sun's corona, invisible in ordinary daylight, shimmers into view, revealing secrets of heat and magnetism. The faintest stars, drowned by sunlight, emerge at the edge of the void, their positions whispering of unseen forces at play. There is a peculiar beauty, too, in the way that eclipses draw together the scattered threads of human curiosity. Across centuries and continents, people have gathered in the path of the shadow, scientists and layfolk, children and elders, united by the anticipation of a celestial event that transcends borders and languages. Each eclipse is a shared moment, a reminder that we are all, in some sense, chasing the same shadow, seeking the same understanding. The techniques have grown ever more sophisticated. Today, satellites and space probes observe eclipses from above the clouds, free from the vagaries of weather and atmosphere. Robotic telescopes, synchronized across continents, record every nuance of the sun's dimming and brightening. Computers analyze patterns in milliseconds, tracing the evolution of coronal mass ejections, mapping the dance of magnetic fields. Yet, at its core, the chase remains unchanged. A patient waiting for the alignment of bodies, the fleeting passage of shadow, the revelation that follows in its wake. Even now, as night deepens and the world falls quiet, the memory of those who have stood in the shadow lingers. Eddington, peering through his telescope as the sun vanished behind the moon. Hipparchus, marking the edge of the Earth's shadow on the moon's bright face. Janssen, capturing the spectral fingerprint of helium from a continent half a world away. Each, in their own way, caught a glimpse of something vast and strange, something that, for all our knowledge remains just out of reach. And so the story continues. The shadow moves on, tracing its ephemeral path across the face of the earth, beckoning new generations to follow, to observe, to measure, to wonder. In the aftermath of darkness, in the lingering glow of discovery, fresh questions arise. What else might we glimpse in the moments when day becomes night? What new truths wait to be revealed, hidden in the interplay of light and shadow? The night is not yet over. The shadow has given up some of its secrets, but many more remain. As the last echoes of the eclipse fade, a new silence descends, a pregnant pause filled with possibility. Somewhere awaiting the next alignment, the next passage of darkness, another watcher prepares to chase the shadow once more. There is a hush that falls over the world in the moments before an eclipse. It is a hush deeper than silence, as though the very air remembers ancient stories and trembles at the threshold of the unknown. The birds grow quiet. Even the wind seems to hold its breath. Somewhere, perhaps in a bustling city or a remote field, people gather, eyes turned skyward, hearts fluttering in anticipation, united by a longing that is older than the written word. The stage is set for a celestial drama that has for millennia drawn humankind out beneath open skies, bound in awe and sometimes in fear. Let us linger within this hush, for it is in these expectant moments that the connection between eclipses and humanity reveals itself most vividly. What is it about these fleeting alignments that stirs such profound feelings and thoughts? Why do we, creatures of earth and certainty, find ourselves so moved by the brief shadow of one celestial body upon another? To begin to answer, we must journey back through the corridors of time, long before telescopes and scientific explanations, to when shadows were omens and celestial events were messages from gods. Ancient peoples watched the sky with a curiosity as keen as our own, but it was laced with uncertainty and wonder tinged with dread. The sun and the moon were not just objects, but living forces, deities whose moods could shape the fate of empires and the yield of harvests. Consider the Babylonians whose astronomer priests stood upon ziggurats, scanning the horizon for signs. They recorded eclipses in cuneiform on clay tablets, developing mathematical schemes to predict their occurrence. Yet even as their understanding grew, the eclipse retained its aura of the uncanny. In their eyes, a solar eclipse, when the day turned to night, was a dire portent. Kings would don disguises, and substitutes might be appointed to the throne on the chance that the god's wrath would strike the wrong target. Far to the east, in ancient China, the story was told of celestial dragons devouring the sun or the moon, and the people would beat drums and clang pots to frighten away the beast. Eclipses were occasions of communal anxiety and ritual, moments when heaven and earth seemed perilously close, and the boundary between the human and the cosmic grew thin. Yet, as the centuries passed, Chinese astronomers learned to predict these events with increasing precision, their records stretching back more than 2,000 years. The terror of the unknown gave way, gradually, to the satisfaction of understanding, but the sense of connection to the cosmos and to one another remained. Eclipses have always been more than simple astronomical events. They are, in a sense, shared experiences that transcend language, nation, and era. The Great Eclipse of May 28, 585 BCE, for instance, brought a sudden halt to a brutal battle between the Medes and the Lydians in what is now Turkey. Both armies, caught in the grip of the inexplicable darkness, laid down their arms, interpreting the eclipse as a sign that their gods wished for peace. The sun's disappearance, so rare and so complete, transformed enemies into allies, if only for a moment. Here is the power of the eclipse, to unite by virtue of shared bewilderment, to remind us of our smallness and our common fate beneath the sky. The Greeks, too, found themselves both unsettled and inspired by eclipses. The philosopher Anaxagoras, in the 5th century BCE, dared to propose that the sun was not a divine chariot but a fiery stone, and that eclipses were the natural result of the moon's passage between earth and sun. For this he was imprisoned, his rational insight a threat to established dogma. Yet the seed had been planted. Centuries later, the work of Hipparchus and Ptolemy would further unravel the celestial mechanics that governed eclipses, paving the way for a science of the skies. Still, the mythic resonance lingered. The eclipse was both a puzzle to solve and a mystery to savor. As we drift forward through the centuries, the eclipse continues to cast its spell. In the Middle Ages, European chronicles describe eclipses as harbingers of plague, famine, and war. Artists and poets wove their terror and fascination into words and images. Yet, even as science advanced, the emotional impact remained. The eclipse was a canvas onto which each era painted its fears and hopes. Imagine for a moment the solar eclipse of August 21, 2017, sweeping across North America. Millions paused their routines, donning protective glasses, gathering in fields and city parks, sharing the anticipation with strangers. When the sun was finally blotted out, a collective gasp rose. Some wept, others laughed. Children reached for their parents' hands. In that moment, the ancient and the modern merged. The eclipse, as ever, was a bridge across time, a phenomenon that drew together the scattered threads of humanity. There is perhaps something uniquely human in our yearning to assign meaning to these fleeting shadows. The regularity of eclipses is written in the language of celestial mechanics, a ballet of orbits and inclinations, of gravitational tugs and precise geometry. Yet, their rarity at any one location lends them an air of unpredictability, a sense that we are witnessing something fated and special. For a few brief minutes, the familiar order is upended. Day becomes night, the stars emerge at midday, and the world is bathed in a light that is neither of the sun nor of the moon, but of both, intermingled and strange. It is in these moments that the cosmic and the personal meet. The eclipse reminds us that we are creatures of a planet in motion, tethered by gravity to a star and a satellite that dance their own intricate steps. Our myths and our mathematics both spring from the same wellspring of wonder. We are pattern seekers, ever searching for meaning in the shadows, and so the eclipse is not merely an astronomical event, but a mirror. In its darkness, we glimpse our own longing to understand, our fear of the unknown, our capacity for awe. It is a humbling experience, for it reminds us that despite our knowledge and technology, we remain subject to forces beyond our control. The sun and moon do not heed our wishes. Their alignments pay no mind to our calendars or our concerns. And yet knowing this does not diminish the experience. It deepens it. Consider the scientists who have traveled the world to stand in the path of totality. They lug telescopes and cameras to remote atolls and mountaintops, chasing the fleeting shadow. For them, the eclipse is an opportunity, a rare chance to study the sun's corona or to test the predictions of relativity, as Arthur Eddington did in 1919, using the eclipse to measure the bending of starlight by the sun's gravity. Here, the eclipse is both a tool and a teacher, revealing secrets that no laboratory can conjure. But for most of us, the eclipse is not a problem to solve, but an event to experience. It is a pause in the ordinary, a moment of communal attention. We gather, we watch, we gasp. We become, for a brief time, citizens not of nations or cities, but of Earth itself. The boundaries that separate us, language, culture, belief, fade as we turn our eyes to the same sky, beholden to the same cosmic clockwork. There is poetry, too, in the geometry of the eclipse. The sun is 400 times wider than the moon, and the sun is also about 400 times farther away. This perfect accident of proportion means that from Earth the moon can just barely cover the sun, creating totality. It is as if the universe itself has conspired to grant us this spectacle. Astronomers tell us that this coincidence is temporary. The moon is drifting slowly away from Earth, and in a distant future, total solar eclipses will be no more. Our age is blessed with these alignments, a cosmic gift bestowed for a limited time. In many cultures, eclipses have been woven into the fabric of myth and ritual. The Navajo, for example, regard the eclipse as a time of renewal and balance, a moment to reflect and refrain from ordinary activities. They do not watch, but instead turn inward, honoring the sacredness of the event. In India, some fast or bathe in rivers, believing the eclipse to be a time of purification. In other places, the eclipse has been a time of prophecy, of reckoning, of storytelling. The stories endure. They are passed from generation to generation, each retelling shaped by the teller and the needs of the time. In this way, eclipses become not just markers of celestial mechanics, but milestones in the history of human thought and feeling. Each eclipse is unique, not only in its geometry, but in the memories it creates, the questions it inspires, the sense of connection it fosters. One might wonder, as the shadow slips away and the light returns, what remains. Do we carry the eclipse with us, lingering in our imaginations, colouring our dreams? Does it change us, even in small ways? Perhaps it teaches humility, reminding us of the vastness and beauty of the universe. Perhaps it kindles curiosity, urging us to keep looking, to keep asking, to keep wondering. Or perhaps it simply gives us pause, a moment to marvel at the improbable coincidence of our existence, here, now, beneath these skies. There is, in the end, no single meaning to an eclipse. Its mystery is irreducible, its impact as varied as those who witness it. For some, it is a sign, for others, a puzzle, for still others, a fleeting beauty. But always, it is a reminder, a prompt to look up, to step outside ourselves, to recognize that we are part of a story far larger than our own. As the world stirs from its hush and the bird song resumes, as the shadows recede and the sun reclaims the sky, the memory of the eclipse lingers. In whispered conversations and hurried sketches, in photographs and poems, in the quiet awe that settles over those who watched, the connection endures. We are, all of us, children of the cosmos, drawn together by the dance of sun and moon. And perhaps, as night falls and you close your eyes, you will find yourself drifting in that space between light and shadow, held for a moment in the embrace of a mystery that has neither beginning nor end. The next alignment awaits somewhere in the future, already written in the stars, already weaving its silent thread through the tapestry of our lives. The eclipse, though past, is never truly gone. It is a reminder that the universe, in all its grandeur and indifference, is also a place of fleeting miracles, of shared wonder, of eclipsed connections that bind us, quietly and profoundly, to one another and to the ever-turning sky. As our journey through the cosmic dance of eclipses drifts to a close, we watch their fleeting shadows melt like a comet tail, fading into the hush of space. May this quiet wonder settle gently in your dreams, inviting peaceful contemplation of the rare celestial moments that grace our skies. When you're ready, return with me for more Dreamtime tales that shimmer softly among the stars.